So right now we're going to be building what is essentially a very simple model viewer in XNA. Go to the area where you have your private member variables declared, and let's add some new ones. First, we need a model object that will be a reference to our pirate hat that we can use. Next is a matrix of bone transforms. This becomes particularly useful when you begin skinning your meshes. This variable is actually necessary to render the model, so we're just going to explain it briefly as we go through. We need to also define the positions of things in our scene, so the camera, the rotation of our pirate hat, the position of the pirate hat, and also the aspect ratio of our game. So first, let's define the camera position. It's going to be of type vector3, a three-dimensional vector, which can also be used to just represent a point in three-dimensional space. So we're going to be using this constructor, x, y, and z. We're going to have our camera positioned at 0x, 8y, and 15z. Next, we'll declare the aspect ratio. We'll set this later. And we'll also declare the position of the hat and the rotation of the hat. So for the position, again, we're going to be using a vector3. And for the rotation of the hat, since we're going to be rotating this hat real time, we'll declare a float called hat rotation. Great, so there's four main methods in an XNA game: initialize, load content, update, and draw. Initialize is where you set things like the aspect ratio, get other resources, set the score to 0, things like that. So here we're going to set the aspect ratio. We're going to be using our graphics object, which is built in for us from XNA. Go to the graphics device, go to the viewport, which is what we see when we look at our game, and take the width and divide it by the height of the viewport. Now, because we are looking at a float and these are all ints, we need to cast these to float to get a reliable decimal answer. So we just put float in the front like that. There's our aspect ratio. If you're running it, for example, 1024 by 768, that should show up as 4 by 3, or 4/3. We're going to set our hat position to the 0 vector, which positions our hat at the origin in three-dimensional space. We'll set our hat rotation to 0, meaning it's looking right at us. And we'll leave base.initialize. Next, we need to go into load content. We'll leave our sprite batch, which is used to draw textures. Not going to be using it right now, but it may come in useful later. We will create our new model now by loading in this FBX file from our models folder. This is the syntax for doing that. Pirate hat equals content. This is a reference to this object over here, a wrapper for the content folder. Content.load, and then this is a generic method. It's taking in a type of model. You can load any kind of content there. It could be a texture 2D or a sprite font or whatever you wish. And we're going to give it the relative path without the file extension to this texture. So in this case, it's models. We have to escape the backslash. Pirate hat, no texture, semicolon. And that will load in our character. Also here, while we're loading the content, now that we have the pirate hat loaded, we need to initialize the bone transforms matrix, which gives us access to the positioning of each mesh within our model. This is going to be an array of matrices, one matrix for each bone in the pirate hat. Now scroll down to the update method. The only thing we're going to be doing in the update method is controlling how far the model is rotated. We want to do this on a real-time basis. So we're going to add in the difference needed to make it rotate at that rate. This line of code makes sure that what we've written is sensitive to the time because we are using the game time object, which is also already provided for us in this project. Now let's scroll down to where the real magic happens in the draw method. And bear with me as this can get a little complicated, but I'm going to try to explain it as well as I can. First of all, let's change the background color of the scene to white. Now, we're going to copy the bone transforms. Remember, theoretically, a bone represents a mesh. And each mesh, at any given time during the game, has a particular rotation, translation, scale, etc. Those are all stored in matrices. So we need to copy each of these transformations into the bone transforms matrix that we have already. We do that by going to pirate_hat.copy absolute bone transforms to, and then we specify our bone transforms matrix. The next thing that we're going to do, and again this is fairly standard for displaying 3D models in XNA, is loop through all of the model meshes in our model. Simple for each loop. And within here we need to loop through each effect in the mesh, which should be a basic effect. This iterator effect gives us access to the different matrices for each of the meshes. The first matrix that we're going to set is called the world matrix. The world matrix defines how the object looks in 3D space. The first matrix is just the base matrix for our object. We're going to multiply this matrix by any rotation and also any translations that may have taken place. However, we're not translating anything yet, just the rotation. We're going to create a Y rotation matrix using the hat rotation. It's a very handy helper tool there. And also create a translation matrix. So you'll notice if we decide to update the hat position, this line of code will already move it for us. Now we set the view matrix. This matrix will be what we see, how the camera projects onto our scene. We're going to use this handy method, matrix.createLookAt. We're going to use our camera position. We're going to use the 0 vector, which is again the origin, which is where our pirate hat is. And we also need to specify what direction is up to the camera. In this case, we haven't been spinning the camera or anything, so we just use vector3.up. Lastly, we need to set the projection matrix. This defines things like the field of view, exactly what we can see with the camera. It also defines where the near plane and far plane is for our vision. So we're going to be using this method, matrix.createPerspectiveFieldOfView. For the field of view, we're going to be using radians. If you were to hold your arms out at a 90-degree angle and imagine that you could see everything in that 90-degree field, that's your field of view. Generally in games, 45 degrees is about the norm for the field of view. So we need to convert that to radians. Thankfully, XNA has given us a math helper library. mathhelper.toRadians. And we'll just use 45.0 degrees. For the aspect ratio, we've defined that earlier. The near plane distance we'll leave at 1.0, and for the far plane, we'll put at 10,000. And then the last thing to do here is enable the default lighting on each of these meshes. Since we haven't done any other lighting design, we want to be able to see our object. And then, outside of that for each, we'll just draw the mesh. Very simple. And that's it for coding. Let's push F5 to debug our project. You notice we got an exception, error loading models, file not found. So let's stop debugging, and the reason for this is because we have not included this file in our project. Simple fix. Let's press F5 again. And there's our pirate hat. It's untextured, but it certainly works. So that's it for getting your model into XNA. Next thing is to learn how do we texture a model and get that into XNA.